Hi, I'm Mireia Montaner from Christophe Magnon Laboratory in Paris, and I'm interested on the effect of incretins in the brain. So, brain controls both glucose homeostasis and food intake. It is constantly receiving peripheral hormonal signals, among them the signal GLP-1. In pathology, GLP-1 is involved in metabolic disorders like diabetes, as we know, which at the same time are related to olfactory problems, triggering a loss of sensory interaction with food. Among the structures presenting GLP-1 receptors in the brain, we can find the olfactory bulb. In the olfactory bulb, its receptors, GLP-1 receptors, are located on the mitral cells, as I show you here in green. Thus, GLP-1 signal from periphery can be perfectly integrated in the olfactory bulb and transmitted to the limbic system, including the hypothalamus. As we know, as it has been shown for the NTS by Stefan Trapp, there's also the presence of PPG neurons in the olfactory bulb. In this context, our hypothesis is, does GLP-1 by its action on the GLP-1 receptors in the olfactory bulb impact energy balance and the physiological and physiopathological conditions? For that, to check our hypothesis, we work with diet-induced obese mice compared to control mice, and we proceed with different type of experimental series, which are injections, acute injections of exondin 4, exondin 9, or GLP-1 by itself locally in the olfactory bulb. Each one of these experiences is always followed by an OGTT. It's important to know that for all the experiences, each mouse has been its own control. So now let's start with the results. This is mice phenotyping after 3.5 months of high-fat diet and control diet, and show diet, We can see an increase of body weight and body fat to the detriment of lean body mass. So obese mice, after 3.5 months, are already obese. We wanted to determine the diffusion of exondin 4 injected locally in the olfactory bulb, and we can see that there's the presence of the molecule and in the olfactory bulb, here, fluorescence, but its absence elsewhere, especially in the hypothalamus. I show you now the results of OGTTs and insulinemia after acute injection of exondin 4 in the olfactory bulb. Control mice are glucose tolerant and have a proper glucose-induced insulin resistance. Obese mice are glucose intolerant. Its glycemia is still high at the end of the test compared to controls. After injection of exondin 4 in the olfactory bulb, glycemia dramatically decreases at all time points of the OGTT. In effect, exondin 4 is making obese mice glucose tolerant, significantly increasing its insulin secretion. GLP-1 results are similar from those obtained with exondin 4. As I show you here, there's no prominent results. There's no significant differences for control mice, but still, one more time, a sharp decrease of glycemia after GLP-1 injection in the olfactory bulb. Nevertheless, this time there are no significant differences on insulinemia. Contrary to exondin 4 and GLP-1 results, we have exondin 9 results, increasing glycemia in both group of mice, control and obese mice, worsening glucose intolerance in obese mice with no changes on insulinemia. Altogether, our work unraveled the GLP-1 pathway in the olfactory bulb as an effector on glucose homeostasis. Thank you.